What's up guys, welcome back to the channel. This is the last video whereby we'll be solving problems with compound angles without using a calculator. I already wrote the problem that we're going to solve. This is the problem that we're going to solve right there. Cos negative 165. So this one is a bit special guys. This one is quite a bit special because you might need to use some different method, and also you will need to understand how the backwards trigonometric ratios work, or when we look at our cos backwards, how does it actually work. So let me try to draw the cos diagram here. Alright, I'm gonna use a different color so that you can able to notice here. So when we go this way, you need to understand that 0 is still 0, but this one is gonna be negative 90, here is gonna be negative 180, and there's gonna be negative 270, and then going back to the origin, which is negative 360. Alright, so when we go backwards, how do we represent each quadrant? Remember, this is still the fourth quadrant, but since we are going backwards, this is going to be negative theta. On the fourth quadrant, when you go backwards, this is how we represent the fourth quadrant. And then the third quadrant, when you go backwards, this is how we represent it. Negative 180 plus theta. Alright, and then the second quadrant, when you go backwards, is negative 180 minus theta. And then the first quadrant, when you go backwards, negative 360 plus theta. So this is how we do it, guys. As compared to the time whereby we go forward, this is how we actually do it going backwards. So how are you gonna solve this problem that we are facing right here now on our left? This problem here on our left. Now, there are many methods of solving this, but there is one that I find it very simple. You won't get confused as long as you know that how we represent our quadrant when you go backwards. Now let's look at this. So remember, negative 165, where is it happening? It's happening between negative 180 and negative 90. So it means it happened on the third quadrant, and on the third quadrant we know that cos is negative, but here's how you're supposed to write it to make your life simple. So you can say cos, and then we say negative 180, and then how do we represent the third quadrant? We add it with theta, but now we're not going to use special angles. If you use special angles, you won't able to get the answers. So rather use 15. If you say 180 plus 15, it will take you to 165. The reason why we use 15, we know that you can also expand 15 using special angles. Now we know that this is 180 rule, even though we are not using special angles, 180 rule. So we know that on the third quadrant, cos is negative. So we're gonna have cos negative 15. Alright, so from here now we see we are going back to our problem that we were solving on the first question, or the second problem on the second video when you're solving these problems. Now this negative, you can just leave it here whenever you're solving. So you can expand this and using the compound. So how can we add 15 so that how can we use special angles so that we get 15? We can say 45 minus 30. Now 45 minus 30, it gives us 15, by the way. So from here, as you can see, we can start using our compound angle. So just like our previous video, we know that cos A plus B or minus the same as cos A and then cos B, plus or minus, I hope I will have enough space, sine A and sine B. Alright, so we know that it's gonna be like that. Now let's continue. If you haven't watched the previous videos, I actually did something similar to that, and if you want to know about the compound angles formulas, there is a video which is the first part of this playlist, so you'll find all these compound angles formulas. So let's continue. So we have our minus here, or subtraction, so we need to expand this using compound. So how are we going to do this? This is going to be cos 45 multiplied by cos 30. Again, you need to know your compound angles. If this is negative, this is going to be positive here. So if between 45 and 30, if it's negative, when you expand this, we're going to have positive here. And then we're going to continue and say sine 45, and then we're going to say sine 30. Alright. And then we start now solving our problem. So let's continue. Now when you solve here, we're going to use our special angles from our right angle triangles on our right. So we're going to refer to those two right angle triangles on our right, guys. So what is cos 45 when you look at those triangles on our right? So cos 45 is supposed to be adjacent over hypotenuse. So adjacent is 1 and our hypotenuse is square root 2. Then we multiply. And then what is our cos 30? Our cos 30 is supposed to be adjacent over hypotenuse. Now our adjacent is square root 3 over 2. Alright, then we add, because there is an addition here. Then we look at sine 45. Sine 45 is 1 over root 2. Alright, then multiply. Then we look at sine 30. When you look at sine 30 on the other triangle, it's going to be 1 over 2. Now this is what we have so far with our simplification. Now if you continue, we're gonna have the following. We're gonna have minus, then do not forget the negative here all along. We came with it from the top, and then when you multiply 1 multiplied by root 3 is gonna be root 3 over 2 root 2. Even the denominators, they multiply each other, plus. And then what we have here, we have 1 over 2 divided by root 2. We have 1 divided by 2 root 2. Okay, so from here you can multiply by negative throughout, or before you multiply by negative throughout, you can rationalize. So when you rationalize, remember you multiply by root 2 over root 2. The reason why we multiply by root 2 over root 2 is because we have root 2 here. So root 2 over root 2 is the same as multiplying by 1. So when you multiply here, we're going to have the following. We're going to have root 6 plus root 2 over 4. So you can leave it like this, or you can continue and write it like this. You can write it like this if you want. Negative root 6 minus root 2 over 4. So this is gonna be your answer when you look at your final answer. Now if you put that on your calculator, you will see that this is your final answer. Guys, I've made 3 examples based on this type of problems, so you can go and watch them. I try to use different signs for these trigonometric functions. So thank you very much, guys, for watching. If you know any other way which is simpler to do these problems, Do not forget to comment on the comment section, like the video, and subscribe to the channel. Share these videos to your friends who are struggling with this type of a problem. Again, guys, if you want to understand much better, I made a series or a playlist of this video concerning each and every concept. So rather watch them in an order so that you can understand much better. Thank you very much for watching. Till next time. Cheers.